In today's module, we will discuss about main memory. Normally, you call it RAM. In other words, when you say that your computer has a RAM of 64 MB or 1 GB, so that RAM is actually called in computer science language as main memory. So before understanding the RAM, we should understand that how to store a bit in the RAM. So we have learned in the previous modules that we can have large number of bits. Those represent some letters, text, audio, video, images, etc. But how actually one bit is stored in the RAM is very crucial to understand. So I need a lot of attention from you, because it is a little bit difficult to understand this concept, but I will try my best to make it very simple. So you are familiar with the concept of OR gate, AND gate and NOT gate. In OR gate, you know that if either of the input is 1, it produces output of 1. AND gate, if both of the inputs are 1, then it produces output as 1. And NOT gate always toggles the input. So this circuit, this is a special circuit which has been made to store one bit in the main memory. Suppose we have already stored an output of 1 in the 1 bit. And here we have control of 2 inputs. So let's put them 0, 0. And let's see what happens. So here we have 1. 1 is coming here. 0 is becoming 1 here, and this 1 into 1 becomes 1, and we have here 1, and 0, 1 is going into the OR gate, which is producing the same output as 1. So this circuit will keep on running, but it will contain the previous value which we have stored as 1 using this flip-flop in a particular bit. This is because we have control of these two inputs. If we remain these two inputs as 0, 0, then this circuit will retain its previous value. So let's little bit change the input, the upper input to 1. Let's see what happens. So other is same, 0 is becoming 1, 1 is already stored, and then 1 is coming here, and it is having no effect. So now let's see, we have already stored 0. Now let's see what happens. This 0 is coming as 1. This 0 is coming here in this AND gate as 0. So you know 0 and 1 become 0. So this 0 is coming here. But as we have changed this input from 0 to 1, this OR circuit will produce an output of 1. So this means whatever was stored previously by this flip-flop, if we change the upper input as 1, this will store the value of 1, whether it was 0 previously or 1. Now change this input as 0. Because we were saying that on the input of 0, 0, it will retain its position. So let's see now what is happening. So this 0 is going here, 1, and this 1 is coming from upside. So we are 1, and this AND gate is producing output of 1. And we have one input 0, other input as 1, so it will produce 1. And similarly, if we change the lower output as 1, so this flip-flop will start saving the output here as 0. You can try it. So if we conclude that in this flip-flop, if both inputs are 0, then it retains its value. While if the upper input is changed to 1, it is start saving the output as 1, and if lower bit is changed to 1, then it is start saving the output of 0. So this is how in each bit the value of 0 or when 1 is stored. So this means on a particular bit, if we want to change its output or we want to store 1 in that bit, we need to put here 1, and if we want to store 1, we need to put here 1. So these are the points from where we can control this circuit. So this is how we have learned about how to store 1 bit in a memory. So main memory is organized in small cells and each cell is of 8 bits. So household devices like microwave oven at your home or other small devices which have some data which they store, so they may have few hundreds of cells. However, large computers might have billion of cells available inside in their main memories, which we have already learned that if your memory is 1 terabyte, so it is saving around about 1 trillion bytes inside, and on each of trillion byte there are 8 bits, and on each of 8 bits such a circuit is invoked to store the values. And if we see the byte site organization, so we write a byte from left to right. So on left side we say it is the most significant bit or higher and other order end, and on the right side we say it is a low order end or least significant bit. So it is similar as we store data in decimal. For example, when you say 250, 100, so this 2 is the most significant in decimal because it is representing 2000. Similarly, in this bit pattern, the most left bit is known as the most significant bit. And each cell has a cell address. So starting from cell 0, cell 1, cell 2 and so on, we have trillion of cells and each cell has a cell address starting from cell 0. So other circuits in the computer can store and retrieve data in each cell. That's why we call it random access memory. Access means you have an access to all cells here. So if you want to store data into this cell, so you can straight away save in this location. So such a saving or retrieving data is known as random access. And then there is a concept of DRAM, which is a dynamic random access memory, which stores bits as tiny electric charge and it refreshes it many times in a second. Then there is a concept of SDRAM, which is synchronous dynamic random access memory, and that has been made to reduce time to retrieve content from each cell. So if we summarize our today's module, we have learned about main memory, and we started with a flip-flop, that how each bit the data is stored inside the computer. And then we have learned about memory organization, then what are the cell addresses and how those cell addresses are retrieved and accessed by other circuits and other programs. And then we have discussed briefly about RAM, DRAM and SDRAM.